Alright guys, this is a video of notes for today, and this is only if I cannot get there to be on Zoom with you guys. And today's topic is angles of elevation and depression word problems. Essentially, these are trig word problems, okay? So what I'm going to do is there's 10 problems on tonight's assignment. I'm essentially going to work the first 4 problems with you, and then I'm going to leave you to do the second page on your own, which will be problems 5 through 10. So the last 6 problems on your own, alright? First, a quick note. I'm getting a couple emails about this where it's square root of 2 times the square root of 2 equals 1. All right. This is not the case. All right. Let's talk about this. A couple different ways to approach this. One, square root of 2 times the square root of 2 equals the square root of 4. And the square root of 4 is 2. All right. And this makes sense because what does the square root of 2 actually mean? When I say the square root of 2, I'm saying what number times itself gives me 2. So the square root of 2 is a number that when I multiply it by itself should give me 2. All right, so just a quick little footnote to help you guys with that special right triangle quiz. All right, so angles of elevation and depression. In general, what I want to show you is an angle of elevation problem, right? So here I am, I'm standing, right? And I go ahead and I go outside and I've got the flagpole, right? Flagpole out in front of school, okay? Now here, if we go ahead and we take a look at our flagpole, as we're standing outside, if we look straight forward, right, we have kind of just this horizontal line that is our gaze where we're looking forward. If I go ahead and instead tilt my head up to look at the top of the flagpole, I'm creating right here an angle of elevation. So that angle is called the angle of elevation. All right. So the angle of elevation is if I'm looking forward and I look up, the angle that my eyes make from looking forward to looking up, right? So what we have here, as you can see then, is a right triangle, right? So this is what problems are going to look like with an angle of elevation or an angle of depression, okay? Now, in general, this will also be, we'll find that this will become our angle of depression, right? So what do we mean by angle of depression, right? Well, let's just go ahead and think about a very depressing scenario, right? I'm standing at the edge of a cliff. Oh God, is there anything more depressing than that? And as I go ahead, I'm looking out, right? And then I hear the most beautiful sound, and it's dolphins, right? And there's dolphins that are playing in the water. I have no idea how to draw a dolphin. This should be terrible. Good, yes, it looks like a goldfish. Nailed it, right? So here, I go ahead and I look down to see the dolphin, okay? Now watch what's going to happen here, right? There's 2 things of note here, right? As I look down, this becomes my angle of depression, okay? Right there. So again, where's my right triangle? My right triangle is right here, right? There's my right triangle, right? But also check this out, right? I can also connect over here and have a right triangle there. Now think about this, right? That means that if both of these are perpendicular, I've kind of got like a rectangle going on here, right? And that would make these opposite sides parallel. So what that would mean is that this angle of depression is alternate interior to the fish's angle of elevation, so they would be congruent, okay? So in general, when you get your right triangle, what I always encourage students to do is however you've got it, always draw your right triangle at the bottom, right? And it can be like that, it can be like this, all right? And it doesn't matter. If they give me an angle of elevation or an angle of depression, it's always going to end up down here at the bottom. This will always be my angle of elevation or my angle of depression. Okay, make sure you're reading problems carefully because sometimes they might throw something in there to try to trip you up. They might tell you that, hey, a ladder's leaning against the house and the angle it makes with the house is some number of degrees. That's going to be different, right? If this is my ladder and this is my house, this is the angle where the ladder meets the house. If it tells me there's a ladder leaning against the house and gives me the angle of elevation, it's talking about this angle down here. So just be careful with that. All right. So now let's go ahead and get to some word problems. If you want to go ahead and download today's homework, you can do that. Like I said, I'm just going to be working through the first 4 problems with you. If you want to go ahead and set maybe them up with me and then maybe try to solve them on your own or try them on your own and then see how I do them, that's perfectly fine. Just make sure you're understanding the content here. All right. So question number 1. right? We've got our friend Brian, and he's out flying a kite, right? Obviously, he doesn't have the same weather wherever he is as we do here, right? So Brian's kite is flying above a field at the end of a 65 meters of string. If the angle of elevation to the kite measures 70 degrees, and Brian is holding the kite 1.2 meters off the ground, how high above the ground is the kite flying? So let's go ahead and draw our situation here, right? So here's Brian, right? And then here's Brian's kite, right? A little tail, right? And so let's go ahead and take a look at what's going on here, right? So where's my right triangle? I go over, right? I go down, right? And then I've got this going up here, right? And this is the string that attaches to the kite, okay? So there's my right angle right there, okay? Now let's talk about a few things that are going on here. They tell me that it's at the end of a 65 meters of string. So here we go, right? We've got him holding the string right here, and the string goes up to the kite there. So I know the length of this is 65 meters, right? That's my hypotenuse. And then they tell me here that this is 70 degrees, my angle of elevation, right? So he's looking forward, and then he looks up to the kite 70 degrees. Okay, now they give me this one other piece of information here, and we're going to come back to that piece of information at the end, right? But I want to know how high above the ground is the kite flying. So this is x. I want to talk about its altitude right here, right? So I go ahead, I look at this problem, and this is a basic trig problem, right? Here's my side opposite. Here's my hypotenuse, right? I go ahead and I write it down. Some old hippie caught another hippie tripping on acid, right? So there we've got it. Well, this is opposite and hypotenuse. This is a sine problem. So I go ahead and I write sine of 70 degrees equals x over 65. And Mr. Sapkowski has taught us when the number's on the bottom, we just kind of move it out front, and we get that x equals the sine of 65 times the sine of 70. Okay. Now again, you want to make sure that your calculator is in degree mode. If you're not in degree mode, you're gonna have a bad day. All right. I imagine most of you figured out how to do this correctly the other day, but just to make sure, I'll just drop my calculator. I can't find it. All right, everybody, calm down. It's gonna be okay. CD player. Seriously, where's this calculator? This is embarrassing. Back there it is, sorry. So here, if I go ahead, I go to my calculator, right? Remember, I'm going to turn it on. I go ahead, I go to mode, and I go down to where it says degree, over, and enter, right? Make sure degree is highlighted, right? I hit clear. And I know this is hard to see on the camera, so don't worry about that too much. But I go ahead and I type in 65 sine of 70. And because I'm in degree mode, I find out that this is 61 meters off the ground, right? So I find that x is about 61.1 meters, okay? So here, that's what they're telling me right here, is that this length is 61.1 meters, right? 61.1 meters. But that's not where the ground is, right? The ground is all the way down here. Well, that's that last piece of information they give me, right? They tell me that he is holding the kite 1.2 meters off the ground. So this is 1.2 meters here. And that means that this is 1.2 meters here. So now I can add these two numbers, 61.1 plus 1.2. I can say, and I'll use a sentence because that's how we should answer a word problem, right? The kite is 61.1 plus 1.2 is 62.3. 62.3 meters off the ground. Okay. So there's my answer to number 1. Not too bad, right? All right, let's go ahead and take a look here at problem number 2. From an airplane at an altitude, height of 1,200 meters, the angle of depression to a rock on the ground measures 28 degrees. Find the distance from the plane to the rock, right? So again, here, let's go ahead and draw kind of our situation here, right? So what is this going to look like? Well, I've got my airplane here, right? Clearly it's a Boeing 737. Right, and there's maybe a thing coming out here, and I got like a wing coming out here. I don't know. I'm terrible, but you get the idea, right? So there should be a wing on the other side too, huh? All right, so there's my airplane, right? And so here I am. I'm riding up front, and I'm gazing forward because I'm flying my plane. And then all of a sudden I'm like, ooh, look at that pretty rock on the ground, because that's something that happens all the time, right? So here's like that rock that's on the ground, right? So again, I can draw my right triangle one of two ways, right? A lot of people will go ahead, look here, and draw that right triangle. But I'm telling you, just make life easy, right? Draw your right triangle always the same, right? So here, this is the ground, there's my rock, there's my right triangle, right? And again, I've got an angle of depression, right? So I can go ahead, I can mark my angle right here, right? But I know alternate interior angles, it's going to be the same as this angle right here, all right? Nothing too special, right? So let's go ahead and fill in our numbers here, right? They tell me that it's flying at a height of 1,200 meters. That's how high the plane is off the ground. So right here, this is 1,200 meters. They tell me the angle of depression to the rock is 28 degrees. So I can put 28 degrees up here, or I can put 28 degrees down here. I'm going to use the one down here because I like this right triangle, right? Find the distance from the plane to the rock. Here's the plane, here's the rock. This line represents the distance, so that's going to be x for me, okay? So I'm looking for the hypotenuse here, right? So I go ahead, I label my sides. This one is opposite the angle. This one is the hypotenuse. And look, we've got another sine problem, right? Opposite and hypotenuse again, right? So I go ahead here, sine of the angle, 28 degrees, is equal to the side opposite, 1,200 over x. I know that when x is on the bottom, I just switch sides there, and I get x equals 1,200 divided by the sine of 28 degrees, right? And then here I'll just use my calculator to do that, right? So here the plane is whatever that number is, meters away from the rock. Again, I'm not worried about that. I know you can do that on your own, all right? So again, I just want to make sure we're drawing these pictures appropriately and we're able to solve them, all right? All right, the next one. Problem number 3. We're moving right along here. So we did problem number 1, problem number 2. Now we're taking a look at problem number 3. All right. So problem number 3. What we got going on here? Problem number 3 tells me that from the point on the ground 12 feet from the base of a flagpole, the angle of elevation to the top of the pole measures 53 degrees. How tall is the flagpole? So here, we're actually just measuring from the ground, right? So again, here's my right triangle. Right? That's always going to be a right triangle, right? I can draw it up front. It doesn't matter, right? But here's the ground, right? And I know that I'm 12 feet away from the base of the flagpole, right? Here's my flagpole, right? So I'm 12 feet from the base. And then they give me an angle of elevation. They tell me the angle of elevation is 53 degrees. And they want to know, how tall is that flagpole, right? So x, the height of the flagpole is what I'm looking for. So I go ahead and I solve this problem, right? Here's opposite, here's adjacent. Clearly this is a tangent problem. So the tangent of 53 equals x over 12. I move the 12 out front. X equals 12 times the tangent of 53. And then you guys know how to put that in your calculator, and you know how to write your sentence, right? The flagpole is x number of feet tall. Okay, next problem. And this is a fun one, right? I really enjoy this problem, right? So from a plane flying due east at 265 meters above sea level, the angle of depression of two ships sailing due east measure 35 degrees and 25 degrees. How far apart are the ships? Oh, that's a great question, right? So what's going on here is I got a couple things going on, right? I've got my airplane, right? I'm getting even better at drawing, right? Watch this one, ready? All right, look at that beautiful plane. Nice, nailed it, right? And then down here I've got ship 1 and ship 2. Perfect, right? And so this is kind of like what my picture looks like, right? So let's go ahead and take a look here at what I've got going on. So we're going to find that there's two triangles, right? So the first triangle is going to be the plane to ship 2. All right, so here's plane to ship 2. All right, we're going to solve this problem, okay? So here, to find the plane to ship 2, right, what they're telling me is that the plane is 265 meters above sea level. So there's my plane. That's how high it is above the sea. Now it tells me the angle of depression to two ships, right? So look here, right? There's going to be two triangles. There's going to be this triangle, and then there's going to be my red triangle. So I got a green one, and I got a red one, okay? Now they tell me the angles of depression of the two ships, right? So as the plane's looking forward, right, he looks down, right? He looks down 25 degrees. So this is 25 degrees, and he sees this ship. And then he looks down even further, right? He goes ahead and he looks down that way, 35 degrees, right? And he sees the second ship, so this is 35 degrees. And I want to know how far away are the two ships. So here, this distance right here is x. So what I'm going to do is I'm going to find two numbers, right? I'm going to go ahead here. I'm going to find this distance. How far away is ship 2 from directly below the plane? And then I'm going to find this distance. How far away is ship 1 from right below the plane? And if I take this red distance and I subtract this green distance, I'll be left with this black distance, okay? So I'm going to go ahead, we'll just call these, since I'm using x for that distance, I'll just call this one A and B, right? It doesn't really matter. We'll call this one A, we'll call this one B, all right? So let's go ahead and set up our trig problem looking at our red triangle, right? So regardless, this angle, 25, this is opposite. I know that this is adjacent, right? So this is a tangent problem. So the tangent, right, of 25 equals opposite 265 over A, all right? So what do I know? I know that A equals 265 divided by the tangent of 25, okay? Now we're going to go ahead, we're going to take a look at B, right? Same thing, right? I've got opposite, I've got adjacent. This is another tangent problem, so I know that the tangent of 35 is going to equal 265 over B. That means that B equals 265 divided by the tangent of 35, right? And now I can just subtract those two numbers, right? Because I know if I take my big long red line and I subtract my green line, I'll get x, right? So I'll use my calculator to help me out with this, right? So I'm good. I can just type this in exactly as it appears. I'll do 265 divided by the tangent of 25 minus 265 divided by the tangent of 35. And when I hit enter, I find that they are 189.8 meters apart. So x is 189.8. Right? And you could find this number, then subtract them, and you'll get 189.8 meters. So I'll write my sentence. The ships are 189.8 meters apart. All right? Hopefully you found these problems to be pretty accessible after doing the trigonometry homework the other night. I'm sorry we didn't get a chance to go over that today. Please know what's really important here is that you're able to draw the picture to set up the problem. Okay? Even if you cannot solve the problem, I want you to set up the picture and label as much information as you can. All right? Now the good news is for the problems I've assigned you, at least 3 of them have pictures. Right? So you can just label the picture there. But you should always draw your right triangle and label the information. All right? The trig solving, if you're struggling with that, I can help you with that, right? Right now the skill is drawing the picture. All right, you guys can email me if you have questions, but like I said, if you're watching this video, it's because I lost power, so I probably won't be able to get back to you soon, but just do your best, and I will touch base with you guys next time we're together. All right, take care.